Okay, everybody, good morning to you. I hope you guys are doing well. Yes. Uh, what you meant by your homework? What do you mean? Okay, let's take a look here. So, assignment homework 4. Oh, that's test 4. Sorry. So, homework 4 was done. Is that right? But then some people said there was an issue with this here. So you say 1, 2, 4, odd, 31, and 34. Is that what you were talking about? Oh, hold on. You're doing, are you talking homework 4? Okay. All right. So we're going to look at homework 5. Okay. Now you're saying some people weren't able to do this part. Okay. You okay with that? Some people weren't able to do this. Should send the worksheet. Yeah. Okay. So it's the same worksheet. Yeah. That's true. That's true. So you're going to do 19. You're going to do these, essentially what I said, these exponential equations. Yeah. So you can do those exponential equations. That's right. Okay, that's true. All right. Okay, let's take a look. You guys are not in statistics yet. You are in 125. And, remember what we're doing here. Go back over here. Remember you have in the assignment portion, let's just talk about a few things here for 125, right? First of all, you guys remember, when do you have your final exam? Okay, let's kind of look for that. I think I could, let's go here. I am actually going to put it up here. So remember, when do you have your final exam? Yeah, it's right up here. So Math 125, if you guys can't see that, it's on my website. It is Tuesday. It's May 31st on Tuesday. At what time? 9:30 a.m. to 11:30 a.m. Okay, 9:30 a.m. to 11:30 a.m. (9:30 a.m.) So that's next Tuesday. So okay, and that's also when your test 4/study guide is due. Is that true? Okay, do you guys know that? It's also when that's due. Say yes. Yes. All right. So, okay, and then now if you say, well, where is that test 4 anyway? It's in the assignment portion. It's right here. So, you can open that up and share it with you guys. So notice what I've been doing. I've been actually working on here. This is some of the things you already had. We already lectured on, right? It's going to be on your final. All these things, right? So I'm trying to lecture on the things that, like we talked about this yesterday, right? Sign analysis. Remember that process? And then what do you think we're going to start to talk about today here? Good. System of equations. Now, you might say, well, where's that on your website? Well, let's go to my website. We'll start to do some more of these things here. To get you started, the system of equations is down here. Okay. I'm going to copy that link. I'm going to put that here for you. We're just start to get started on those. So we start to make sure we could get all those things in that we're supposed to get in for the course here. And so let me give you guys kind of an example of what a system of an equation is. Let me write this down. You have x minus 3y is -1, and then you have 2x plus y is 5. Okay, so this is what we call a system of equations. So let me ask you guys this question here. Has anybody ever solved a system of equations in their life before? Have you ever seen these kind of things? This is known as a system. You say, why do we call it a system? Well, there's a few reasons. Because there's really now here what? Two equations. You guys agree with that? You say, what are the equations? Here's my first equation. Here's my what? Second equation. So first of all, a system is defined to be, right, two equations. And then you also have how many unknowns, by the way? How many variables? So you have two equations and two what? Unknowns. What's an unknown value? Do you guys know? An unknown value is called a variable. So what are the variables here? X and Y. X and Y. Are you guys okay with that? So you have two variables, X and Y. The question that really people want to know is, what are the values of X and Y? So that's what they want to know. So what are the values of X and Y? Now, when we had courses like beginning algebra, okay, I want you guys to note the beginning algebra course. So I'm going to go back here really quick to share with you guys from beginning algebra. That was Math 115. So back in beginning algebra, I had you cover the same topic, actually. So you cover this in beginning algebra. This is here, Algebra Lecture 10, solving a system of equations, Algebra Lecture 10. And so I have a video on the beginning algebra versions. That's Math 115. They don't offer that anymore because they say everybody knows this stuff anyway, right? They don't offer that course because you already know how to do all that stuff, right? So what I'm saying is, what kind of methods were there? Do you guys know? Back in beginning algebra. You had the graphical method. You see that there. It's called the graphical method here. So, okay, and then you had the method known as the addition method. You go, oh, okay, the addition method. And then we had one known as, I used to have to cover all these, the substitution method. So there were three methods back in beginning algebra that went over this stuff, like Algebra Lecture 10. All right, you guys see what I'm saying? And that video is here. So this assumes people kind of know what's going on because now you have the intermediate algebra version. You go, what's the intermediate algebra version? Well, the methods you have now that you're going to use here. Okay, so I'm going to give some notes. Math 115, because I'm going to describe this to you here, right? In Math 115, you solved a system of linear equations. And here's what that meant. Remember, every linear equation can be represented by a line. So here's L1. And you have another linear equation represented by another line called L2. Okay? So what do you guys know that's supposed to happen? Because this is line 1, this is line 2. So what's supposed to happen, but it doesn't always happen, is that these lines intersect at a point, at an address, right? There's an X value and a Y value. So they intersect at a point, X, Y. Right there, L1 and L2. So that's the deal here with this equation. Now, this doesn't always happen. I just want you guys to know, by the way, you say, by the way, this is called having a solution. You have a solution. The word a means one. So this means there is one solution. And the address is these coordinates. You also have, and I'll say, by the way, this is what we call situation 1. You have one solution. Situation 2, here's where there's no solutions. So it's to give you guys sort of a review of what this is. Do you guys remember when you had no solutions for solving a system? Back in beginning algebra, when did that happen? Do you guys know? It's a very special situation. What do we call this? This is when your lines were what? What's the relationship between these two lines? Parallel, outstanding. So you have parallel lines. When you have parallel lines, this is what it meant. They're parallel. What does that mean if they're parallel? They never what? Cross. They never intersect. So I'd rather use the word intersect. So parallel lines never what? Intersect. What does that mean if they never intersect? If a solution is the point of intersection, that's a solution, that address, x1. What does that mean if they never intersect? Do you guys know? What do you think that means, never intersecting? See if you remember. What does that mean? You remember? Question 3. Well, this is the situation when there was what? No, this means no solution because you have no point of intersection. And then here, this is when we call that there's infinitely many solutions. Infinitely many solutions. So what does infinitely many mean? Do you guys know what that meant? Back from beginning algebra? Right? Anybody cover that stuff in high school? Maybe? What does infinitely many solutions look like? Do you guys remember? This is when you're talking about the same line. L1 and L2 are the same. So we have the same what? Line. So why is there infinitely many solutions? Because remember, what's a solution? A solution is where the lines intersect, where they cross. So if they're the same line, they intersect where? Everywhere. Because that's the same line. That line's on top of each other. L1 and L2 are on top of each other. So if they're on top of each other, and there's infinitely many points that define a line, this is when we said, you had what? Infinitely many solutions. So that's the idea. You got infinitely many solutions. Here, you got no solutions because there's no points of intersection. And then here, there's one solution because there's only one point of intersection. So lines are either going to intersect at one point, they're never going to intersect, or they're going to be the same line in which they intersect everywhere. So there's 3 types of solution. One solution, and I'll write it down here, right? So here is one solution. And then here is what? No solutions. There's only a point of intersection. And then here's his infinitely many points of intersection. There we go. So let's see. What do we have here? Good morning, Michelle. Good morning to you. Yes, Shannon, they're parallel. They do not touch. Yes. No solution when they're parallel. Yes. When they overlap, that's right, Shannon. It's the same line. There's infinitely many solutions here. So this is all Back in the day when people studied beginning algebra or elementary algebra or algebra 1. Huh? Well, yeah, you had, again, you had what's called the graphical method. You graph this. You have the addition method. You have the substitution method. If you wanted to watch that video, here it is. You said, Mr. Judge, I kind of like to review these ideas because, they're interesting, they're useful. I'm going to see them in my future, kind of. Anyway, that's kind of the idea here, that this is back in the day from beginning algebra. Alrighty. So now here's the deal here. You say, what happens in this course? Well, this course is intermediate algebra. It's not beginning algebra. And it's very difficult, I know, for students these days to understand this idea, meaning, based on a few things here. It's very difficult because, they place everybody here now in intermediate algebra. But in a college environment, you don't go back. In other words, you don't say this is intermediate algebra, but you're really teaching pre-algebra or you're really teaching elementary algebra. You got to teach what? Intermediate algebra. So like in K through 12, they teach whatever people want to see. So that's kind of the issue. But in an intermediate algebra course, we have additional methods. We're going to look at what's called the matrix method. So that's kind of important for people who are going to take some of these other classes, is that you understand that you have something called the matrix method. Okay, this is a new method. This is an intermediate algebra version of the matrix method. Now, in order to talk about the matrix method and what a matrix is, I'm going to tell you guys, generally speaking, what a matrix is. You guys know what a matrix is? A matrix is we call an array of numbers. And you go, an array of numbers. Yeah, you have what's called rows and columns. Rows and columns of numbers. This is a matrix. Okay, so you go, well, how do I get an array of numbers out of this system? Well, you're going to use here the coefficients. What in the world are coefficients? Well, here's our coefficients, right? The coefficients are another way of saying numbers. You're going to use that number, this number, and you say, what if it's just a y? Well, put a 1 there, this number. So when I create what's called a matrix here, ladies and gentlemen, this is what it looks like. I got 1, -3, 2, and 1. Do you guys see those numbers here? See where I got those numbers? So I'm going to take the coefficients, the numbers multiplied to the variables. That's the coefficients. You guys good with that? This is a pretty interesting method. And then I'm going to say, take a look at this here. You see these equal signs? Put a dotted line. This is what's represented with the equal signs. Because you're going to now get the coefficients here for that system, -1 and 5. Close that in a parentheses. So if I said to you, do you guys know what you're looking at? What is this called? This is known as a what? It's a matrix. You say it's a matrix of what? Of the coefficients. That's what you're looking at. Okay, you guys with me on that one? And I want you guys to get used to this idea here. Okay? You see this top row of numbers? What do you think we call that? Top row. Anybody know? What would we call that? That's called row what? Row 1. And what do you think we call the second row of numbers in our matrix? What do you think? What do we call this? Row 2. That makes a lot of sense. Does that make sense to you guys? Row 1 and then what? Row 2? There it is. All right. So you got a coefficient, and you're going to do this. So what I'm going to do here is this for you guys here. I want you guys to try this out. I'm going to make it up. I'm going to say here you have 3x plus 5y equals 7. 2x minus y equals negative 4. I want you to create your what? Matrix. How would you do that? Put a parentheses, put a dotted line. What are you guys looking for to create your matrix? You guys want to tell me? What are you guys looking for? The coefficient. 3, 5, 2, negative what? Negative 1. And then don't forget you have a 7 and a negative 4. So what do I write down for the first row? 3, what else? 5, what else? 7. Does that make any sense? These are the coefficients. What about for the second row? What do you write down? 2, negative 1, negative 4. So this here is known as what? What do we call this here? Row 1. What do we call the next one? This is known as what? Row 2. And we abbreviate that here. So what do you call this again? This is known as a matrix. Okay, so I want you guys to first practice on creating the matrix. See if you're awake. Negative x plus 3y equals 4. And then I'm going to say negative 2y equals 9. I want you to create the matrix. What would you do when you create the matrix? What are you going to do? You're going to list all the what? All the coefficients. What coefficient is in front of this x? What number is there? What number? Is it negative 1? Okay, so here's the negative 1. Good. And then what comes next? 3. Good. And then what comes after that dotted line? 4. We call this row what? This is known as row 1. Easy? Okay, row 1 now. This is really, if you're awake, where are the A students? What do we have here? 0x. So what do we put here? 0, negative 2, and 9. So here's the deal. 0, negative 2, 9. Those are my coefficients. What do we call this? What is this called? Row 2. So far, so good? Anybody have any questions on that so far? Is that easy? Because you need to know the details. Here's an example. Oops. Here's what I'm going to say. We're going to get 6x minus 4y is 12. 2x is negative 9. Okay, so I'm going to say here, Here's question 1. Question 2. X minus 3y equals 0. And 2x plus y equals negative 1. 3. X plus y is negative 2. Y here is 7. So what I want you guys to do here is to create your what? Matrix. Create the matrix, the coefficient matrix. I'll give you some time for you guys to create that coefficient matrix. All right, ladies and gentlemen, tell me what you guys did here. What'd you guys do for these here? What do you guys notice? What is this? 6, negative 4, 12. 2. What if it's missing? What do you put here if it's missing? So that's 0y, ladies and gentlemen. So that'll be 2, 0, negative 9. Is that right? Okay. Now what about this here? If you don't see a number, that's 1, negative 3. There is 0. So I'm writing my matrix coefficient here, 2, and then there's a 1 here because I don't see a number. So if there's not a number, put a 1. That's 2, 1, negative 1. Okay, notice this. Double check. These are all the coefficients. Is that true? So what'd you guys get for the last one? Tell me what the first, because remember, this is my first what? Isn't this row 1? Row 1, is it true? And then what do you have here? This is row 2. This is row 2. We have to communicate. Tell me what row 1 is. What is row 1? Row 1. What is that? You don't know what row 1 is going to be? What are the coefficients? 1, 1, negative 2. Okay, and then 0, 1, what? 7. Good job. You have to be able to read the coefficients, ladies and gentlemen. If you can't read the coefficients, you can't proceed. Is that right? And I also want to point something else out. What do you think we call this? Here. This is actually column 1, column 2, column 3. Are you guys okay with that? So you have rows, you have columns. This is called column 1. What is this? Column 2, and this is column 3. So you have to be able to read what you're looking at. This is column 1. What is this? What's the next one? If you can't read it, you can't do it. What do we call the next one? Okay, and what's this one? Column 3. Okay. Column 1, column 2, column 3. You guys get the picture, okay? And so let me give you guys some facts about what you could do with these entries here. So here are some matrix facts. There's 3 facts, ladies and gentlemen. Facts 1, you can interchange your rows. And you say, what do you think that means to interchange rows? You can switch them. Okay, so for example, what we're saying you can do, if this is 1, 2, negative 6, and I got negative 1, 4, and 3. What do you think that means? That means this matrix is the same as negative 1, 4, 3, 1, 2, negative 6. Do you guys notice what I just did? Yeah, I switched the rows. Here's row 1. Where is it now? It's down here. Here's my row 2. Where is it now? Up here. So what did we just do? We switched the rows. Okay, so that's one thing we could do, interchange our rows. The second thing we could do here, ladies and gentlemen, is we can multiply a constant. You know what constant really means? It means number. It just means number. We can multiply a constant to any what? To any row. Six, negative 3, 4, 0, 1, negative 2. Okay? So here's an example of what I mean. I'm going to multiply 2 times row 1. Okay? I can multiply a constant. In this case, the constant's what number? It's 2. What am I multiplying the number 2 with? Every entry in row number 1. Now remember, row number 1 is on top here. Is that right? Okay, so I can multiply 2 times 6. What do I get? What's 2 times 6? Okay, what's 2 times negative 3? Negative 6. What's 2 times 4? 8. Good. You know what you're looking at? A new row what? A new row 1. Okay, so that's a new row 1, ladies and gentlemen. Your row number 2 stays the same. So this is going to be 0, 1, negative 2. So this row stays the same. What changed is your row 1. Okay, you guys okay with that? We can multiply. We can do that. That's allowed. Here's what I'm going to say now. Right? I'm going to show it to you guys again. This is an example. Let's give you guys another example. If I had here negative 1, 4, positive 5, 6, 1, and 0 here. I'm going to say multiply, take the number negative 3 and multiply it to row 2. What's your new matrix going to be? Okay, because we're looking at what's called elementary row operations. Well, what does it tell me to do? Take the number negative 3 and multiply that to what? Which row? Okay, so what do you get now? What's the first entry now? Negative 3 times 6 is negative what? Is that negative 18? What's negative 3 times 1? What's negative 3 times 0? So, ladies and gentlemen, this is your new row number what? 2. Okay? Row 1 stays the same. Okay, so this will be negative 1, 4, and 5. So we can do these elementary row operations here. Okay, let me try to draw an arrow if I can. I guess it doesn't want me to draw an arrow. There we go. Whatever. Give you another example. Here's my matrix. Let's say it's 5, negative 2, 1, negative 1, 0, negative 3. I want you to multiply, let's say, negative 2 times row 1. Okay, and also I'm going to say this. Have you guys do two things. Multiply 3 times row 2. Okay, give you guys a few minutes here to do the arithmetic. See what you got. Okay. All right. So what did you guys get as answers here? Right? So give me your new row 1. What do you get for your new row 1? Negative 10. What else? 4. Okay. And then? Outstanding, ladies and gentlemen. There you go. Okay. You guys okay with that one? All right. What about 3 here? What's the deal with 3? It's negative 3, right? What else? Okay. And then? What's 3 times negative 3? Negative 9. Remember what you're doing here. This is your new row what? 2. This is your new row what? Row 1. This is the old row 1, so you guys can see that. This is the old row 2. So you multiply every entry with that number. Is that right? Okay, should we have you guys try one more? Because it's an important step. These are important. You have to be able to do this, these kind of computations. I'm going to say here, we got 4. We got negative 5. And I got 2. And then I have negative 3, negative 1, and 0 again. So what I want you guys to do is this. I want you to multiply negative 1 to row 1, positive 2 to row 2. I want you to get a whole new matrix by multiplying your rows by those constants. Let's see what you get. Okay. What does that negative sign mean? Good, it's negative 1 times row 1. So what happens when you multiply every entry in row 1 by negative 1? You get what? Negative 4, 5, and negative 2. Good. Okay, now do the same for row 2, but this time you multiply by 2. What's 2 times negative 3? Okay, 2 times negative 1. And 2 times 0. Outstanding, ladies and gentlemen. That's the second operation you guys can do. So notice times row 1. Second operation. Okay? So I'm going to give you the third thing that can be done is you can add rows together. You say, what do you mean I can add rows together? In other words, let me give you an example. You can have 2, -1, and 6. This can be 3, 4, and -2. Okay? So this is how we add our rows together. I'm going to say this. I'm going to take row 1 and add it with row 2. Okay? Row 1 added with row number 2. So here's my row 1. Okay, take elements in row 1. You're going to add it with those in row number 2. Okay, but I'm going to put an asterisk on the second one. Do you guys know why I put that asterisk there? This is an important detail. I might even put that in red instead. It's an important detail. What do you think that means? Well, what you're going to do is, see, when I say take the elements in row 1 and add it with row 2, you're going to say, here's a 2. 2 plus a 3. What's 2 plus 3? Okay, it's 5, but where do you put the answer? You see how I have the asterisk on row 2? That means put your answer in row 2 here. That's what that means. Put the answer in row 2. So when I go to the next computation, -1 plus 4, what's -1 plus 4? It's positive what? 3. You put your answer in row 2. That's why you put the asterisk always in row 2. Okay. And what's 6 plus -2? So the asterisk is in row 2, ladies and gentlemen, because that means you have a new row 2. You changed row 2. It's new. That's why you have the asterisk there. But then what do you do with the entries for row 1? You just copy them down. Just copy them down, and you have the same row 1, but a different row 2. There you go. So we can add rows together. Okay, you guys see what I just did? We can add rows together. This is kind of important, ladies and gentlemen, in solving a system, doing arithmetic. I know it doesn't seem that way, but you'll see what I mean. You go, oh, I have to know how to do this arithmetic. So I'm going to do this again. Take row 1, add it with row 2. I'm going to put the asterisk there. The asterisk, in other words, what changes is always you're going to see here, we have the asterisk on. Give you guys some time to try this out. Okay, let's see. What do you get now, right? What do you have here? You got row 1 right here. Is that right? And then what do you have? Good. So when you add the contents of row 1 with row 2, right? You take -1. Let's go back. -1 plus 1. What's -1 plus 1? 0. Good. Where do you put the answer? Good job. Outstanding. So you guys can do this. And then I'm going to say this. What's 2 plus 5? Put the answer in row 2. Outstanding. And then I'll say, what's 4 minus 1? Where do you put the answer? Outstanding, ladies and gentlemen. What do you do with row 1, though? What are the entries? Yep, exactly. Good job. There it is. Okay, so what changes is the entries here in row 2. Okay? All right, so then I'm going to have you guys add some rows again. I'm going to say this is 4, -2, and 5, -3, 2, and -1. But you know what I'm going to say now? I'm going to say take row 2 and add it in row 1. On the right, you'll always have your asterisk. See what you get now. Okay, what do you guys get as an answer? Yes, we go. What's 4 plus -3? Is that +1? But where does that go? Good job. First row. You say, how do I know? Because this is, you have your asterisk there. That tells you where to put the answers. Yeah. It's just telling you put your answers in row 1 when you do your arithmetic. Now, what is this? What's -2 plus 2? Where do you put your answer? Good job. Good. And then 5 plus -1 is 4. Where do you put your answer? Good job, ladies and gentlemen. That's what you do. You put your answer there. So what do you do then with the row 2 values? Just copy them what? Down, okay? You guys okay with that? So this is doing arithmetic with the rows. This is going to be an extremely important process. It's one of the main parts of using this method. And now I'm going to give you guys another example. I'm going to put some things together. -1, 4, 0, 2, 3, -3. So when I'm going to say this, I'm going to say, you're going to take 2 times row 1, and you're going to add it to row 2. You're going to create a new matrix here, okay? So the constant is 2. 2 times row 1, this is the top row. Then you're going to add it with row 2. Here's row 2. But remember, your asterisk always goes over here. This tells you where to put the answer in for your arithmetic. What do you guys get now? What do you think? Take 2 times row 1 and add it with row 2. So what am I saying? 2, yeah, multiply what? And what do you get? Okay, now add it with, what do you get? And where does that answer go? There you go, ladies and gentlemen. Double check. These are elementary row operations. You're doing arithmetics with the rows here. Now let's do it again. The next entry. You read it. 2 times what number? 4. What's 2 times 4? And then you add it with 3. What's 8 plus 3? Good. And you put your answer in row 2. Okay. 2 times 0 is what? And then you add it with negative 3. What do you get? Good job. Just negative 3, ladies and gentlemen. This is a pretty big deal. And then what do you do with row 1 entries? You just bring them down. You do nothing. There you guys go. This is using elementary row operations here. Okay, now I'm going to do this row here. I'm going to say get negative 1 times 4. And I have a 0 there. I'm going to take the prior one. I'm going to say this. I'm going to say take negative 1 times row 1 and add it with row 2. Put your conclusion in row 2. Okay, so negative 1 gets multiplied to every entry in row number 1. And then you put your answer, or you add it with row 2. But you're putting your answer in row 2, okay? Okay. Negative 1 times negative 1. So I'm going to take negative 1, and I multiply it with negative 1. What do I get? And then what's positive 1 plus 0? And I put that in. Where do I put it? Row 2. Good. Oh, I'm just going through an exercise, Shannon. I'm just giving some examples about how to do arithmetic. We're going to talk about that tomorrow, so stay tuned tomorrow. Okay, negative 1 times what number? 4. Isn't that negative 4? Is that true? Negative 1 times 4 is negative 4. Happens when you add it with 11. What do you get? 7. Good. Put it in row 2 because you say, where's my asterisk? Right here, row 2. Okay, now, negative 1. What's negative 1 times 0? And add it with negative 3. What do you get? Remember, you put your answer in row 2. There's your asterisk there. Is that right? And then what do you do with all the rest? Bring it down. Okay, you guys okay with that? You want to see one more? Let's give you one more, ladies and gentlemen. I'm going to say here you have 3, 5, negative 2, 3, 4, negative 1. Take negative 1 to row 1 and add it to row number 2. So, I want to make sure you guys understand some arithmetic here. Orange is row 1. So we're going to multiply negative 1 with every entry there. Then we're going to add it to row 2. Where do I put my answers? Where's the asterisk? Row 2. Okay, you guys okay with that? An asterisk? No, that's an asterisk. You guys know what the asterisk? What is an asterisk symbol? That's just kind of like a symbol saying, hey, put your answer there. That's all. So negative 1 times positive 3 is negative 3. But when added with 3, what do we get? Where do I put my answer? There you go, ladies and gentlemen. Negative 1 times positive 5 is negative 5. What's negative 5 plus 4? Well, negative 1 times positive 5 is negative 5. Plus 4 is negative 1. Where do you put your answer? Okay, good. Okay, now, negative 1 times negative 2 is positive 2. Add it to a negative 1. What's 2 plus negative 1? Good. And you put your answer in row 2. So all of the other entries you just bring down, ladies and gentlemen. So you know what you did, what this is called? Working with you're doing what's called elementary row operations. Let me write this down. I want you guys to know, so when you talk about it, you have some language there. No, these are called elementary, okay? Row what? Operations. You know the word operation is another word of saying arithmetic. Add, subtract, multiply, and divide. Just to let you guys know. So you're doing arithmetic with rows is what that's saying. And that's a necessary thing to do when I teach you the matrix method. So in other words, today I'm prepping the table. I'm setting the table. What do you mean? What do you think I mean by that, setting the table? I'm getting the plates out. I'm getting the cups out. I'm getting the what? Napkins out. I'm getting the forks, spoons, and knives out. And what do you think we're going to do then? What are you going to do with all those tools after I set the table? Then we're going to eat. Is that right? What are we going to eat? I'm not going to say carnitas. Some of you guys don't like carnitas. I like carnitas. What are we going to eat? Huh? Math? I'm setting the table, doing elementary row operations, because tomorrow I'm going to show you guys how to solve a system using the matrix method, and you have to know how to do elementary row operations. You guys see what I mean? Because I'm setting the table today, so tomorrow we can eat, and you guys didn't tell me what we're going to eat. Natalie, what are we going to eat? No. Chips? Okay, if you guys want to eat chips, we'll eat chips. I'll bring my chips. Should I bring my chips tomorrow, you guys? I'll give you guys some chips tomorrow. We'll see you guys tomorrow. You guys. Okay, so ladies and gentlemen, we got to finish this off, right? You guys have to answer that last question on the study guide. Okay, now here's a game plan here. Remember, we're going to ask you guys, this is your matrix, right? This is called an augmented matrix. And I'm going to give you a definition here, okay? Definition of what we call row reduced echelon form. I'm going to put an asterisk. That's an asterisk. That's just not an ugliness. Asterisk, 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 asterisk. But here, I'm going to put a 0. I want a 0 there, ladies and gentlemen. You want to know something here? Your game plan is this. You're going to take this original matrix. This is the game plan, ladies and gentlemen. And you're going to take that original matrix. I try to draw an ellipse. And you're going to try to write this in a row-reduced echelon form. What am I really saying? You know what I'm saying? I'm saying this. What I want here in row number 2, if you look at row number 2, I don't think I want to do that, but I want to make this entry in that left corner 0. I want to make that entry 0. The question I have now is, how can I make this entry? I want to make this entry here. How can I make it 0? How do we make that 0? What do you think I do, ladies and gentlemen? You know how we do this? Here's what you do. You're going to use elementary row operations to make that entry what? 0. You're going to use elementary row operations. And that's how you make it 0. Okay, you guys okay with that? That's how you're going to make it 0. All right, okay, so you say, well, that's how I make it 0. Well, how do we do that? Do you guys remember? Here's what I'm going to ask you guys here. We're going to do some arithmetic like we did yesterday. So hopefully you guys enjoyed the arithmetic yesterday. You know what I'm going to say? I'm going to take -2. I'm going to multiply it to row 1. And I'm going to add it to row 2. Okay? Take a look at this detail here. I'm saying take -2, multiply it to the first row. Isn't that what we were doing yesterday? Right? Then I'm going to say, then add it to the what? Add it to the second row. Let's see what happens. What do you think is going to happen? So tell me, what is -2 times +1? Do you guys know? What is that? -2 times +1. What is that going to be? Okay, then add it with +2. What do you get? All right? You're going to do this operation. I just said -2 times row 1, add it with row 2. What do you get? You just had this yesterday. Thank you. You get 0. Isn't that what we're trying to do? Yes, because you put the answer in row 2. Ladies and gentlemen, you get 0. What do you think? Is that pretty good? Yes, it is pretty good. Okay, now continue. What's -2? This is like what we did yesterday. What's -2 times -3? And then it's +6, is that right? Then add it with 1, what do you get? Good job. Okay. What's -2 times -1? +2, and then you're going to add it with what? 5. What do you get now? 7. Outstanding, ladies and gentlemen. So what do I do here with the first row numbers? You keep them as they are. You guys see that here? All right. So, ladies and gentlemen, we're doing the arithmetic that we did yesterday. Did we get 0 there? Say yes. All right. We're going to try another one. We're going to try more. Here's another example. All right. And I'm going to get this here from my website. I'm looking at my website. All right. I'm going to say this. I have 1. I have 5. I have 2. I have 4. I have -1. And I have 8. You know what I want to do, ladies and gentlemen? I want to make this entry what again? I want to make that entry 0. That's my game plan. Make that corner number 0. And you say, well, how do we do that? Using the elementary row operation. So I'm going to change that number so the lower left corner is 0. You know how I'm going to do it? How do you think I'm going to do it? I'm going to take the number here, -4, multiply it to row 1, then I'll add it to row number 2 here. Here's row number what? 1. Here's row number what? 2. All right, you guys okay with that? And good morning to Louise. Good morning to you. And good morning to Michelle. Good morning, you guys. Good morning. Okay. Here we go. So you're going to tell me this, right? I'm going to take the number -4, and I'm going to multiply it to row 1, and I'll add it to row 2. Okay? That's going to make this entry 0. Okay? Let me show you guys. What's -4 times 1 now? Isn't that -4? And then +4, I get 0. And remember, I always I'm going to put my asterisk here. That means I put my answer in row what? 2. Didn't I make this entry 0? Yes, I did. And that's going to be important for us. So we're going to try to make that entry 0. Good. All right. Let's do the rest now. -4 times 5. What's that going to be? Positive or negative? It's -20 because a negative times, I'm sorry, it's -20, yeah. Negative times a positive is a negative. -20 plus a -1 now, what do you get? -21. Good. Okay, good. What's -4 times 2? Positive or negative? -8. And then -8 plus 8 gives you what? 0. Good job. So this row, this is 0. What do I do with the other entries? Copy them down. There you go. Pretty good? You see how you're making that 0? All right. I'm going to go to another page. I'm going to have you guys try this here. Okay? I'm going to say this is going to be 3. This is 2. This is -8. This is 6. This is -1. This is +4 now. And so you say, what am I going to try to do? You see that lower left corner? I'm going to make that 0. Can I show you how I can do that? I'm going to ask you to do the arithmetic. Here's what you're going to do. You're going to take -2 times row 1, and you're going to add it to row 2. I'm going to ask you guys to give me that matrix here. Okay, see what you get. Give you guys a few minutes to do your arithmetic. This is what we're saying. That goes in row 2 here, okay? So that's your scratch work, and we got the 0 there, okay? Now, you're going to have to do the other entry. So maybe say I need more scratch work. Negative 2 times 2 plus 6. What's negative 2 times 2? What's negative 4 plus 6? And the entry goes in row 2. Does that you guys find that helpful? Is that helpful, you think? Oh, yep. No, you're right. We had negative 1. You say, Mr. Judge, that would be even more helpful if we added negative 1, and that'll be negative 5. Good. Okay. All right, negative 2 times negative 8 added with 4. Is that right? We did that one. We did that one. Okay, what's negative 2 times negative 8? What's 16 plus 4? And there you go. What do you do with the entries in row 1? Stay the same. So, ladies and gentlemen, this is important for us to do. Now, you might say, why is this so important to get that 0 down there, right? So let me go through the process here for you guys. Remember, we're solving a system, and what we first did, believe it or not, in our notes, they're going to ask us to solve x minus 3y equals negative 1, 2x plus y equals 5. So this is called a system of equations. We talked about that yesterday. So your first step is to create the what? What did I just do here? I did it yesterday. I said what it was. What did I just do here by looking at these numbers here? What did we create? What is this called? Anybody remember? What is it? What are you looking at? It's a matrix of the coefficients. Yes. And we got to give out our chips. Come up here and pick your favorite one. Whatever's left. I don't know. Pick your favorite for whatever's left. Okay, good. Good, thank you. Now, what are we going to do? Now, what I'm going to say, here's your game plan, ladies and gentlemen. This is the most important point. Here's a game plan. You want to create this matrix here. What do we call this matrix? Anybody remember the name of the matrix? There you, it's the, what is it? No, close. What is it? Nope. What is it? It's close. You got it. What is it called? Yes, you could come up and get your chips. Whatever's left. Okay, now I want a 0 in that lower left corner. How do we get 0? We got to use the row reduced echelon. We got to use what? What's it called? Yes, elementary row operations. Come up here and get your chips. Yes, you're going to use elementary row operations. Okay, so tell me, how do we get a 0 in that entry? This is going to be big. This is the key. How do I get a 0 down there? What do I multiply to row 1 and add it to row 2? What? Well, you have to tell me specifically. What do I multiply to row 1? Yes, come up here and get your chips. -2. Outstanding. -2. So we actually did this one. Here's what I mean. -2 times 1 plus 2. This is what we're doing, right? What's -2 times 1 plus 2? It is 0, and that's the whole idea. Get a 0 in that corner. But I have to do the other computation. -2 times -3 plus 1, and -2 times -1 plus 5. What is that going to give us? We said 6 plus 1 is 7. We said 2 plus 5 is 7. Good. What do we do with the entries here? Leave them alone. Outstanding, ladies and gentlemen. There you guys go. So this is the game plan. And once you get this, you're gonna put a happy face. All right, here's a happy face for you guys. I'm gonna show you guys this process. You should be happy with that now. Now you say, what do I do with this? Here's what I'm gonna say. Here's what you guys do next. Use these coefficients and back substitution to solve the system. This is what you do. Now, before I say to you guys this, right, this is my first row. Is that right? And then let's find another. This is my that's my first column. Here's my second column. Here's my third column. Okay? For the first column, that's the coefficients for my x variable. Is that right? This is the coefficients for my y variable. Is that right? What does this line symbolize? What does this line represent? This is my equal. So you say, what am I looking at? Here's what you're looking at. 1 times x minus 3 times y equals -1. You guys see that there? Then I have 0 times x plus 7 times y equals 7. But what do you know about 0 times any number? Isn't that going to be 0 here? Okay, you guys see what I'm saying? These are my coefficients. So what this means is I really have x minus 3y equals -1 and 7y is 7. Ladies and gentlemen, this is gold here. This is why you did everything. Put a double happy face. Because remember, this is what they're saying. Use the coefficients. And then now we got to use this thing. We're going to color it pink. Whose favorite color is pink? Anybody? Oh, there you go. We're going to use back substitution to solve the system. Back substitution. Okay? Back substitution. Now, you might say, what is back substitution? This is back substitution. I like that. Pink and black. When does that Stranger Things start again? It reminds me of the 80s. Any of you guys born in the 80s? Uh-oh. What? You guys aren't born in the 80s? In the 90s? Not the 80s. Good for you. And the rest of you guys are born in 2000s? Okay. Well, you know, back in the 80s, pink was big. The movie Pretty in Pink. Anyway, this is back substitution. You start with a 7y equals 7. Okay? Can you guys solve that for y, by the way? You say 7y is 7. How do you guys solve for y? You divide both sides by 7. What does that mean y equals? Well, 7 over 7 is 1. You know what you have? You have the y value for the solution. What do you think you use for this now? You're going to plug this into the first equation. This is back substitution. So y is 1, and that goes here, okay, because that's y. Now, how does this help you? Right? Plug that value back in. What you get? You know what you get? You get this. You get x, 3 times 1. What's 3 times 1? 3, and that equals -1. Could you solve for x now? Yes, you can. Yes, you can, because you add 3 to both sides. What does x give you? What's -1 plus 3? +2. Ladies and gentlemen, you know what a solution is? You guys remember we said a solution? That's the point of intersection. That's the x value and the y value. What's your solution here, ladies and gentlemen? X is 2, y is 1. That's what you're looking for, ladies and gentlemen. This is called the point of intersection. That's your solution. X is 2, y is 1. That's what we're looking for. So you might say, what is a solution again? Go back to the original equation. X is 2. X is 2. Y is 1. Remember what it meant to be a solution? That when you plug the values back in, you get a what? A true statement. Okay. This is 2 minus 3 equals -1. Is that a true statement? When I plug in these values, do I get a true statement? Yes. And then I have what? 2 times 2 plus 1. Is that 5? Because I'm plugging it back in. 2 times 2 is 4. 4 plus 1 is 5. That's a true statement. True, true. Let's use pretty in pink in honor of the 80s. So, ladies and gentlemen, this is what we mean by the values of x being 2 and y being 1 as a solution. It also corresponds to, if I go all the way back here, what I started the lecture with. This is the point of intersection. These lines intersect at the point, a single solution at 2, 1. There you go. That's what we're saying. So we've come full circle, ladies and gentlemen. This is the process for solving by the matrix method a system, and it's a very powerful, very, very powerful method. Now you might say, well, let's see another. You guys want to see another one? Because you can't just see one. They can give you x plus 5y equals 2, 4x minus y equals 8, ladies and gentlemen. We're going to solve the system. Anybody remember what the first step is? What's your first step? You're going to create a matrix with the coefficients 1, 5, do the dotted line, and 2. Isn't that my first row of coefficients right here? 1, 5, and 2. Okay. Then I got 4, -1. There's the -1. And then what's the last one? 8. There we go. All right, you guys okay with that? Now, what do we need down here again? We want that to be 0. Is that right? Okay. Now, this is really extremely important. How do you get that number to be 0? What do I do? I'm going to have to take a number multiplied to row 1, and then I have to add that to row 2. This is what I do. What is the number that will give me 0 there? Come on down, Ashley, and pick out your chips. It is negative what? 4. Good job. I always remember your name because that's my daughter's name. And I call her Ashlita. Do they call you Ashlita? No? I'm the only one who calls my daughter Ashlita then. They call you Ash? You like that? Yeah. We call her Ash too. I never called her Ash. I always call her Ashlita. Ashlita for little Ashley. Anybody have an embarrassing nickname? What did they call you, Natalie, growing up? Natalie. Is it just Natalie? Did you give you another name? Jose, what was your nickname? Uh-oh. Don't know what that means. Okay. All right. Let's do the arithmetic. You guys ready? -4 times what number? Times 1. and you add it to 4. What's that going to be? There you go. Isn't that the whole idea, to get 0 in that corner? Yes. But we have to do the other arithmetic. Negative 4 times 5, add it with a negative 1 here, right? So isn't that negative 20 minus 1 is negative 21? And then negative 4 times 2, add it with 8. Do you guys think doing the scratch work is a good idea? Very good idea. So negative, isn't that going to be negative 8 plus 8? Is that also 0? Okay, good. All right, here we go. What do you do with the first row? Just copy it. Now, what does this all mean again? You guys know what it means? Put 1 times x plus 5 times y is 2. And then, I can put 0 times x, and I could put negative 1 times y, and that equals 0. But we know this portion is going to be a 0. So you really have x plus 5y is 2. Negative 21y is 0. So, okay, let's ask you guys a question now here. Let's see if you know this answer in the process. What do we use now? What's this process called? I think you guys are going to miss the sounds. What do you guys think? Do you hear them in your dreams? What do we do now? What is the process known as now? What happens now? Back sub. Okay, Jose, come and get your chips. You rather what? You don't. Oh, you don't eat chips? Good for you. No, it's all right. Good for you. Should we give somebody else your chips? The gentleman in blue. Come on down and get your chips. Do you guys know each other? You see them around? Hey, you want to do me a favor? You see you see these other two in the corner there? Give them a bag of chips. Get one for each. And the gentleman behind Jose, get the bag of chips. Yeah, give them whatever that. The remaining students. So make sure everybody has a bag of chips. The remaining. Okay. I got to get rid of those. If I don't get rid of them, I eat them, and I'm not supposed to eat that stuff. Huh? I'm diabetic. I can't. It raises my blood sugar. Yeah. So you're going to use back substitution, ladies and gentlemen. Which one do you start with? You start right here. You start here. Negative what? 21y is 0. Divide both sides by negative 21. What is y going to be? Y is 0, because 0 divided by any number is 0. This is my y-coordinate solution. What do I do with that y? I plug it back in the first equation. So that's x plus 5 naught times y, 5 times 0, and that'll equal 2. And you know what that means? Because this portion is 0, right? That means x is what? X is 2. And you found a solution, ladies and gentlemen. Final answer? X is 2, y is 0. You are done, ladies and gentlemen. Okay, you are done. What do you think? This is the matrix method, ladies and gentlemen. This is the matrix method. We're going to do another. 2x plus y equals 0. 4x minus y equals negative 6. Remember, we start with the what? Create your matrix. Two, 1, 4, negative 1, 0, negative 6. 2, this is 1, 0, 4, this is negative 1, and there's negative 6. Okay, you guys okay with that? All righty. Now, what do we want in this corner again? Come and get your chips, Ashley. You got to get rid of the box. You want that portion to be 0. Does anybody want to tell me, what do I multiply to row 1 and add to row 2 to get a 0 there? Okay, come on down and get your chips. It's -2. Look at that. You guys know what you're doing. Is that right? Oh my God, you guys are doing the matrix method. Let's do the arithmetic now. -2 times 2, that's the number. Added with 4, yes, we got 0. That was the number. So now -2 times 1 plus a -1 here. And you get -2 plus a -1 is? Yes, it is -3. Then I get -2 times what? Times 0 plus your -6. Isn't that 0 plus -6, which is? This is your first what? I'm sorry, your second row here. And of course, with the first row, we just bring down the numbers. Okay, you guys okay with that? Now, we're going to write the system again. This is 2x plus 1y, which is y, equals 0. And then I don't have to put 0x because I know what is that going to be. Yeah, so I don't have to put that. I'm just going to have to, I could get rid of it. That's the whole point of getting 0. This is what makes this technique work. That's what makes all of this really work. So we're now ready at this point here to do a process. We call this process again. What's that process known as? There we go. Ashley, come up and get your chips. Did you guys say it at the same time? The two ladies? Did I hear that in stereo? It was you, Jose? You don't want to give somebody else your bag? Who do you want to give this time? Okay, the person, right, come and pick up your chips. If you want, you could give them to your friends. You got to make sure that box is empty. All right. Okay. Can I ask you guys this question? What's y? What's the y value? Okay, the gentleman comes up and gets his chip. Actually, I heard that at the same time. So all three of you guys could come up and get your chips. Yeah, you divide both sides by -3, right? And a negative over a negative is a positive. And ladies and gentlemen, there's your y value. Okay. Anybody get the x value? Here's y. Here's y. Uh-oh. It's -1. You sure are correct. Answer is -1, +2. This is your one and only solution, ladies and gentlemen. All right. And that's using the matrix method. Okay. I'm going to get you guys on this one, though. 3x plus 2y is -8. 6x minus y is 4. Okay? Remember these coefficients. And that dotted line here. This is our matrix. Okay. Now we want to make that lower left corner, right in here, we want to make it 0. So we can only do that by doing what? A number times row 1 added to row 2. What number is it going to be? Is it? No. -2. Okay, come on down and get your chips. What was your name again? Jocelyn, you have a nickname growing up? What do they call you? Josie? Oh, there we go. Oh, you don't want to say the other one. Don't want to say the other one. I don't blame you. Don't blame you. Huh? It's a -8 up in the right corner. Okay, let's do our arithmetic now. You say, what's the arithmetic? Only take -2 times 3. Add it with 6 is -6 plus 6. We got the 0. We knew that already. The next one is -2 times 2. Okay. Added with a -1. So I get -2 times 2 is -4 plus -1 is? Be careful, -5. All right. -2 times -8, add it with 4. What do you? Well, I think it's positive 20. Why is that? -2 times -8 is positive 16. And then 16 plus 4 is 20. What do you do with the first row again? 3, 2, and what? -8. All right. Now remember, these coefficients correspond to my system here. Okay, so we're going to write down the system again with the variables x and y. And then here you say, well, guess what? You use back substitution here. Okay, we're going to use that back substitution again. So we've got to solve for what? That y first, meaning we say -5y equals 20. When I divide both sides by -5, we get cancellation. It's -4 for y. That y here is going to be what number again? -4. So take a look at what happens here. We get 3x plus 2 times the -4 value should be -8 because y is the value -4. Alrighty. So we get to solve this equation here, but we got to do some arithmetic. This is 2 times -4 is -8. That equals -8. So I'm now going to add 8 to both sides here. I get 3x is -8 plus 8 is 0. If I divide, we get 0 here. So in honor of the 80s, we're going to use that pink. X is 0, y is -4. Here's pretty in pink. This is our solution, ladies and gentlemen. There we go. This is solving our system here. Okay, so now I'm going to share with you guys a very interesting thing. -x plus 3y is 14. x minus y is negative 6. Okay, so be careful with these coefficients here. Okay, so when I create my matrix, I get negative 1, positive 3, positive 14, positive 1, negative 6. I'm just looking at the coefficients here. Okay. All right. So here's going to be something interesting. What do you do here to get this entry to be 0? You just add them. Good. Row 1 plus row 2. Outstanding. Ashley, come and get your chips. Are there any chips left? You want me to give it to somebody else? Yes. Okay, who hasn't gotten multiple chips? Multiple chips? Oh, these are late. So you give it to the ladies or the gentlemen? You got any chips? Yeah, I got one. You got one? Did you want a multiple? I'm good, thank you. Give them to the lady. You sure? You don't need chips? Okay, we'll pass it. You don't need chips either? We need chips. You guys have enough chips? Here, take one. Take them all? Take them all. Give them to your, feed to your fish. All right. Got rid of the chips. Okay, ladies and gentlemen, let's do this here, okay? You remember the scratch work. You're going to take what? This is important. You're going to take row 1, add it to row 2. Yes, you get 0. That's the whole idea. You're going to take 3 plus negative 1. What does that give you? Isn't that 2? You can take 14 plus negative 6. What's 14 plus negative 6? Good job. Okay, now keep the first row the same. Okay, so now you're going to put these coefficients. This is negative x plus 3y is 14. Then you have 2y is 8, ladies and gentlemen. And I'm going to say use back substitution. Two y is 8. We can solve for y. That means y is 4. Yes, it does. So plug in 4 here. Negative x, 3 times 4, and that equals 14. Negative x plus 12 is 14. Subtract 12 from both sides. I get negative x is positive 2. Divide both sides by that negative 1. I get x is negative 2. So we're solving this equation as well. So ladies and gentlemen, our solution is negative 2, positive 4 here. There you go. Okay, so what I want to also say to you guys, there's some very special situations here. Here's a special I'm going to look at these two special situations. You have 2x plus y equals -3. And I have 4x plus 2y is -6. This is a special situation. So when you create the matrix 2, 1, -3, 4, 2, -6. Okay, we're going to create that matrix. Again, you guys know we want this to be 0. Is that right? So how do you think you're going to make that 0? What do I multiply to row 1 and add it to row 2? To make that entry 0, what do we do? Outstanding. -2. So I want you guys to do the entries here. Well, I check something really quick online. Okay, what'd you guys get? You should get what? 0, 0, 0. Okay, and then what do you get up here? 2, 1, -3. Okay, so that means you have 2x plus y equals -3. And you go, what does this all zeros mean? 0x plus 0y is 0. You know what this means? What's 0 times anything? 0. And this is 0. So the second equation, this whole thing is really the statement of what? 0 equals 0, ladies and gentlemen. Okay, now you might say to me, I'm going to say to you guys here, I'm going to color this as a special situation. This is special. You say, what's so special about this? You know what's so special about that? This is when we say they are infinitely many solutions. And I want to just say this here is a true statement. So how you know there's infinitely many solutions in a system is when you get at the very end there a true statement like 0 equals 0. That's how you know. That's special. So remember, I said there's 3 situations. What that means is these lines are the same. So this line, 2x plus y equals -3, it meant that these were the same lines. That's why there's infinitely many solutions. Same lines. Infinitely many what? Solutions. Okay, and then here's the second situation. What do you think I'm going to show you guys here? Remember, what are the 3 outcomes? There's one solution. There's infinitely many solutions. What's the third situation? No solution. Yes, I'm going to give you guys that example of no solution. That's right, Natalie. No solutions. So if you have, for example, maybe you have something like this. X minus 4y is 9, and x minus 4y is 2. Okay? When you create the matrix, that's 1, negative 4, 9. 1, negative 4, and 2. Okay, so we're going to create the matrix. So here's what I'm going to say to you guys. To get 0 down here in the lower left corner, what we've always been trying to do, we're going to take negative 1 times row 1 and add it to row 2. Row 2 will change. Don't you guys think, isn't that going to give me a 0 down there? Because negative 1 times 1 plus 1, that'll give me that 0. So yes, ladies and gentlemen, we get 0 there. Okay? So now if we say negative 1 times negative 4 plus a negative 4, right? Negative 1 times negative 4, what do you get now? 0 again. You go, this looks familiar so far, right? And you get negative 1 times 9 plus 2. What do you get? Negative 1 times 9 is negative 9. What's plus 2? Negative 7. Copy everything else down. And I'm going to remark about this here, ladies and gentlemen. This means x minus 4y is 9. You say, is that 0x times 0y is negative 7? It is, but what's 0 times anything? 0 and 0. So you say, what does this really mean again? Well, x minus 4y is 9. And then you have 0 equals negative 7 here. Now, what do we know about this? Well, first of all, can 0 ever be negative 7? Is that the same? This is a false statement. So if you get a false statement there, what do we say again? No what? Solution. And that's what we say, no solution. So you may not realize this, but these two lines, this is L1, this is L2, the lines are parallel. They never what? Intersect. And that's why there is no solution. No solution. So go back to what I said originally, right? What I said originally, 3 situations. You have a single solution. We've seen a bunch of examples. This is no solution. When your lines are what? These lines are what? Parallel. They never intersect. They never cross. So how do you know when you have a no solution situation? You have a false statement. How do you know it's infinitely many solutions? It's the same line. You have a what? True statement. Okay? And that's the 2 special situations that we had to talk about here. Okay? So, ladies and gentlemen, let me share this with you guys. This is the 2 special situations that we said. No solution. There we go. 2 special situations. And if you look online,